Going to see pulse position modulation and demodulation. In this, how the position of the pulse is going to vary. Actually here we will compare with the pulse width modulation. So whenever the width of the pulse is going to off, from the time period the pulse is going to be on. At that position we are going to get the pulse. See here, pulse, pulse, pulse and pulse position here. And for one cycle how many pulses we are going to get and what is the position of the each and every pulse. This width of the pulse is constant and the distance between the pulses is going to vary if you observe. So whenever the amplitude is increasing, the distance between the pulse is also going to increase. Whenever the amplitude is decreasing, the distance between the pulse is also going to decrease. So that we need to observe in this pulse position modulation. To this kit we have again AF signal generator, next synchronous clock generator, next PPM pulse position modulation and demodulation. If you observe PAM, PPM, PWM, all these are same but the output is different. Why? Because connections are same to same but the output we are going to get the different. And here if you want to observe the PWM in this pulse position modulation also, so at the third pin if you give the connection here, third pin of this IC, you will get the pulse width modulation output. Here we are going to get the PPM output and here third pin we will get the PWM. PWM output has to be given to the input to this 555 timer, then we are going to get the pulse position modulation. Now we will see this one is coming or not, this one is coming or not. Next we will check for the modulation and demodulation also. See here, we are getting the signal. I will go for the channel 1. The amplitude of the signal is very small, so I am going to increase the amplitude. And here the frequency is maximum, so I can go for according to my wish. So this is the message signal or AF signal. Now we need to check for the clock. That's why just I will remove this connection. I will put here. The ground is as it is. Now I will switch on the kit. Now we need to check whether the clock is coming or not. So here clock is not coming. We need to replace the ICs. At that time the lava stand is busy. That's why I changed the kit. Okay, you don't worry. He will replace the ICs next. Pulse position modulation and demodulation. This is the kit. Here also we have the signal source, that is AF signal generator, clock generator, modulator, demodulator. First we will see these two outputs, then give this output as input here, give this output as input here, then see the PPM output. And here also we have the third pin. At the third pin we are going to get the PWM output. If you want you can observe that also. Next, after getting the modulator output, give this output as input here and clock also another input here, then observe the AF output. Now we will check one by one. And here channel 1 we have. So for this type of kit we need to give 8 volts adapter. Previously it is 18 volts adapter. That change you need to notice. Now I am going to switch on the kit. See, we are getting the modulating signal or AF signal correctly. This is the amplitude knob. If you vary this amplitude knob, it is going to change. Okay. Next, just I am removing this connection. I am checking for the clock signal. See, clock also we are getting. See, you need to adjust this one time per division. Then you can note down the time period and amplitude of the clock also. Next, just I am removing this connection. I am going to connect this output of CRO connection here. Then we need to connect two inputs to this modulator, AF as well as clock. AF as well as clock inputs. See, now we are getting the pulse position modulation. So this is the pulse position modulation. For one cycle, how many pulses we are getting? This will not change, and the distance between the pulse is going to vary. If you clearly observe the width of the pulse, the position of the pulse here, distance between these two pulses is going to vary. If you observe clearly, minute difference should be there. Okay, that you need to note down. Next, I told you now you can observe PWM also at the third pin. See, if I put the third pin here, see this is the PWM output. So see here, the width is going to vary. So to know them clearly, I am going to decrease this amplitude, not to 0, but we need to put some amplitude here. Okay. So likewise, for one cycle again we need to note down how many pulse positions we are going to get. That you can compare with the modulating signal to the another channel. So I am going to connect another channel. There I am going to get the modulating signal. See here. See, for one cycle, how many samples we are going to get. For one cycle, you can observe clearly. From here to here, it is going to be one cycle. For one cycle, how many pulse positions we are going to get. See here, this width is not changing, but the distance between the pulse is going to vary. If you clearly observe, the distance between the pulse is going to vary. See here. Okay. Likewise, you can note down the pulse position modulation. Next we will see demodulation. Now just I will give this output connection to demodulator. Then I will give output of this modulator as input to this demodulator. Then one more connection we need to give. That is the clock signal from here to here. See here, we are going to get this phase difference is there always. Okay, nothing to worry about that phase difference. Okay, whenever you have the positive, negative, negative, this phase difference we can have at the demodulation. We can neglect that one, but try to check whether the amplitude level and time period is constant or not. That we need to check. This is about the pulse position modulation and demodulation.